Right, Lamai. Good evening. Can you hear me? Right. Uh, so today, uh, it's an important day, right? Because we will start our sixth lesson, right? What is the lesson? Sixth one, right? Sixth unit, right? So how many lessons left? Now 14, right? So these six. So we finished 5 lessons, right? How many time left? Little bit more than 1 year, right? Little bit more than 1 year, but you have to do actually twice as you did up to here, right? Your time is limited, but you have huge bulk actually, right, to do. So anyway, so here sixth lesson, or we can say generally as we say inorganic chemistry, right? Right. As we generally say inorganic chemistry, right? This is inorganic chemistry, or the name of the lesson is PD block, right? So here, according to the name, right, inorganic, right, what is the meaning? So here we are talking about inorganic compounds. What are the inorganic compounds, right? So inorganic compounds means basically we divided organic and inorganic, right? Like organic fertilizers and inorganic fertilizers, right? So organic means generally carbon, hydrogen and oxygen, right? The compounds contain carbon, hydrogen, only carbon and hydrogen, or carbon, hydrogen and oxygen, right? Generally, yeah, that's the way we are, right? Again, I mean, it can connect with another elements, right? But basically organic compounds have carbon, hydrogen, only carbon and hydrogen, or carbon, hydrogen, oxygen with another elements, right? But here this is about other type of compounds, right? There are some inorganic compounds which has carbon, hydrogen and oxygen, right? I mean exceptions, right? But generally that kind of compounds under inorganic chemistry, I mean organic chemistry. So the remain compounds under inorganic, right? What are the examples? I mean almost all the molecules, right? Carbon dioxide, water, right? But these compounds are small actually, right? When you compare it with the organic molecules, right? These are smaller, you can say like that. Anyway, I'll explain what we're going to learn and those things, right? Just remember, we are talking about inorganic molecules, right? And first I will explain the syllabus, right? So it's important, right? I'll explain about the syllabus. First thing, is it a big lesson? Yes, it's a big lesson. This lesson is bigger than previous lessons, right? It's bigger than first, second, third, those lessons, right? Why am I saying like that? Generally those lessons, the time allocation, right? I will explain using time, right? Period. Number of periods around 30 to 40, right? The previous lessons, right? But this one, it has 64 how many periods? 64 periods, right? So then just you can get the rough idea about the size of the lesson, right? That's why I give the number of periods, right? And next one, right? That's the important, right? When the number of period is bigger, that means it need more time. More time means the size, it's getting bigger, right? More time means it's getting bigger. And What else? Number of periods, right? Then you can get the idea, right? The last one, the thermochemistry, right? The energetics, it's around 41, right? 41 periods. So then think about the size. Huh? Then how about the marks? The most important part, right? Actually, you can achieve lot of marks in this unit, right? So it's very important, right? If you learn this properly, right? If you learn this properly, you can achieve almost all the marks, right? The reason I'll explain when we do the papers also, right? But I'll say it basically. The way they ask questions from these lessons, right? The way they ask, if you know the answer, right? If you know the answer, then you can get the marks, right? If you know the answer, then you can get the marks, right? But if you don't know the answer, then your marks are 0, right? You cannot get any marks, right? So then you may think that's the nature, right? When I say like that, but in another, when it comes to calculations, like even in the normal calculations, or when you go to the previous calculations, right? Just think about that calculations, but thermochemistry, right? Hayes law, those things, right? And the gases, right? Even though you know the answer, you may not get all the marks. Why? You have to show the steps, right? Even though you know the way and the final answer, you cannot get the marks. You cannot achieve, you can achieve, but it's hard. At least you may lose 5% or 4%, maybe 10% from the total marks, right? Why? You have to show these steps. If you miss this step, your answer is correct, but you may lose marks, right? But here, it's not like that, right? They may ask something. If you know, you know, right? As example, the way they ask inorganic questions, they ask to identify, right? One example, they ask to identify. They give some testing, right? So actually, Lamai, this inorganic part, basically they ask questions like analysis, right? Qualitative and quantitative analysis, right? Analysis, right? We call analytical chemistry, right? Analytical chemistry, right? So they get, it's like this. They gave the mixture, right? They gave the mixture, and then they do some experiment, right? They did something, right? Adding some chemicals and heating, right? Blah blah blah, and they asked to identify the element or the compound present in that, or ions present in that sample, right? It's a one way, yeah, right? And another way, it's we call qualitative analysis, right? I will explain those things when we do the papers, right? Just I think I said that quality, right? Qualitative, right? Qualitative, right? So we don't know the percentages, right? That's what is, right? Qualitative analysis, right? Analytical chemistry, two types: qualitative, quantitative, right? Quantitative also came from this part, right? But it's actually based on the, if you know the calculation part, you need inorganic knowledge, but it's based on calculation, right? The third lesson, you need the inorganic knowledge, right? Okay, anyway, what do they do? They just give the sample and they did the experiment and they give the results, right? Blue color, green color, right? Red color gas or colorless gas, blah blah blah, right? They ask to identify. So let's say the ions present in that sample is let's say just copper 2 plus and Mn2 plus, right? Whatever, right? Likewise, then what you have to do? Anyhow, you have to identify it. they don't, I mean, sometimes they ask to write the reactions, but they don't ask how did you identify. Maybe they ask, and then you have to say this ion give this color likewise, right? So that means if you know the answer, just directly write the answer, right? If the answer is Cu2 plus, just put the answer. No way to lose marks, right? I mean, how to lose the marks? You cannot lose marks, right? If you know. But if you don't know, again, your marks 0, right? It's like, how to say that, best or nothing, right? I mean, I don't know, whatever, right? If the mark calculation is 10, you can get 10 or 0, 10 or 0. But remember in calculations, right, like physical chemistry, even though you know nothing, if you write something, right, if you write few things, right, I mean, if you at least if you write the equations, right, then you can achieve some marks, right? So that's the important, right? That's why I say just learn it properly, and then you can achieve almost all the marks, right? So you can achieve marks like that way, okay? So that's the difference of inorganic part, right? So it's hard, but if you know, you can get the marks, right? So and so this is the number of period, then how many marks, right? I said a lot of marks. How much? 22.25, right? Just roughly, let's say, I mean, 22, 23, right? Just think about the marks. I mean, it's close to one fourth of the paper, right? That's why I said it's very important part, right? And it's important for that calculation part. It's coming together. I mean, you need the third lesson, the knowledge from the third lesson, and the knowledge from this part. Okay, right. Yeah, now you know the basic. How to say? I mean, the introduction, right? Introduction means the. I mean, why it's important actually, right? You should know the importance of this lesson, right? Actually, it's important than previous lesson. That's what I want to say, right? Right. Actually, if you are weak for, I mean, don't think like that, right? But let's say if you are weak for calculations, right? If you cover the first, second, and this lesson, then you already achieve around close to 35, right? Close to 35. If you leave fourth and fifth lesson, right, you can achieve 35. I mean, but don't do that. But I mean, I mean, I said, I mean, you can achieve marks, right? If you worried if you cannot do calculations like that, but don't worry, right? You can, if you do the calculation, then again you may pass, but you have to achieve full marks, huh? Right? Okay. Anyway, 22.25, right? Around 22, right? Think how much marks you can achieve, right? Actually, you can get 22 or 22 point all the marks, right? But in that physical chemistry part, I mean, if they allocate 10 marks, but it's hard to get 10 marks, right? Even though you did all the questions correctly, you may lose marks, right? Just understand what I'm saying, huh? Right? You should know the answer, and then you have to show it properly. Then you can get the part. But this here, if you throw the answer, then if it's correct, you get the marks. Okay. Right. So this 22, it's divided into 6 MCQs, and in second part essay and structured essay 16.25. You will get structured essay and essay both, right? The second question of the structured essay is inorganic, and then part C, right? Let me check the paper. Which one? Yeah, part C, right? Right. Okay. Right. Then, so how do we do this, right? So this is a plan, right? So first we will learn group by group, right? Group by group, right? We will learn lot of patterns and different reacts. I mean the reactivity, right? And different patterns, right? Different. I mean exceptions, right? I mean there are some normal patterns and then some exceptions likewise, right? So we learn like that different patterns and those things. So we will go group by group, right? So I plan to do the first group, right? I plan to do the first group today, only the first group. So we will learn almost all the things in first group, right? But as I said, the way they ask questions, it's different, right? You need this theoretical knowledge, but you need analytical knowledge, right? Just keep it in your mind. I'll explain those things group by group, but then we have to know it. No, we have to know how to apply it, right? Analytical, right? You have to analyze, right? Just ගිරව දානවා කියන එක is not enough, not like biology, right? දැනන් හිටියට බෑ, you have to apply it, right? So anyway, let's start. And another thing, how to do this lesson. So your resource book, right? That's the Bible. First thing, that's the Bible, and I will refer the reference that used to make that resource book, right? From some reference, but I'll give few things, right? which not in the resource book, but not that much, right? Few things. Our lesson based on resource book and I mean not the resource book actually. My one based on that teacher's guide and resource book, right? Content, right? So when you study, don't go far from the resource book. Stick to the resource book, right? So I'll follow the order of the resource book, right? Group by group, right? That's the way of that's the order of syllabus also, right? So right, just keep it in your mind. This reference, I mean this resource book made by lot of references, I mean several references, not like I think 5-6, right? Because they use very old reference also, right? So you don't need to know those things, right? You don't need to study references, just study the resource book, right? If you at least, I mean actually if you can, don't do that, don't do this. If you can memorize almost all the things, I mean, not memorize, understand, it's enough. It's almost enough, right? Right? But I mean, I'll explain these things, right? Understand the syllabus, right? And another thing, another disadvantage, if you know more than the syllabus, you may stuck at some questions, okay? Right. Okay. First part, write down the topic S block elements, right? S block elements, subtopic group 1 elements. Actually main topic is S block element, subtopic group 1 element, right? Group 1 element, okay. In here, when we go through the group 1, right? So just think about the group 1. what is the first group 1 element? First group 1 element is hydrogen, as you know, right? Actually, nowadays we just remove the hydrogen from the, I mean, some periodic tables, they put hydrogen and helium into the middle, right? The reason is it's very different, right? Do you know in the universe, you know, there is a theory called Big Bang, right? What is the first element formed from the Big Bang theory, right? It's hydrogen, right? Why? It's contain only one proton and one electron. Oh, some hydrogen contain neutrons, right? Most of them have one proton and one electron. Simple, very simple. Huh? So anyway, this one is very different, right? Actually, this is a gas. Hydrogen is a gas. No need to say, you know that hydrogen is a gas, and it's very different from other elements. So therefore, we have to keep it away, right? So we don't talked a lot about hydrogen. Rather than we talk about other elements, right? Right. So, what is the electron configuration of this one? Electron configuration is S1, right? Right. 1s1, right? 2s1, 4s1, 5s1, right? Likewise. So S1 is the electron configuration. Then when we think about the other elements, so this one, as I said, it's a gas, that means it's non-metal, right? Non-metal, but remember this one in the first group, non-metal. So other metals, right? Other metals, those are called metals, right? This one non-metal, others are metals, right? Actually, this first group, we give the common name we call alkali metals. Alkali, right? Alkali metals, right? This group called alkali, right? Alkali metals, right? So then we have to first we should know where you can find these metals, I mean these elements, right? So we are talking about elements, right? Then we talk about the, I mean, just understand this is the way we discuss all other groups, right? Abundance, right? Availability, right? How it's available, right? What are the elements? Just write down the elements: lithium, right? Sodium, potassium, rubidium, cesium, right? These are the elements. Then you may think, how about francium, right? That's the one called francium. But Lama, we don't talk about francium. The reason is it's a radioactive molecule, I mean element, and actually we don't have enough francium in the world. So the reason, that's the one of major reason, right? We don't have enough francium for the whole world, right? So up to cesium, we are talking about up to cesium, right? We don't talk about the francium. It's a radioactive element. So we talk about the characters of these elements, right? So how you can find those metals, how it's exist in the nature, right? That's the first thing. How? As you know, sodium chloride, right? It's very, I mean, it's well available, right? So then what else? Sodium chloride, or you can say rock salt also. And another way, just remember that this is a different one. NaB4O7 10 dot dot 10 H2O. Right, we call borax. Borax, right? Borax. And how about potassium? That one also, K as sodium, it's available as KCl, right? KCl. KCl. And the new one, KCl, C should be capital, not simple. KCl dot MgCl 2.6 H2O. We call it carnite. Carnalite. Okay, let's write down a little bit, right? I think you wrote the topic is group 1 elements. Okay, first point, all group 1 elements are metal except hydrogen. All group 1 elements are metals except hydrogen. Next point, they have low densities. They have low densities. Next one, electron configuration is NS1. Electron configuration is, third point, electron configuration is NS1. Electron configuration is NS1. Right? Then just write availability, and in front of that or under that write sodium, right? Just write availability, right? Just write availability, and then just write under or in front of the availability sodium, and then short line this one, right? NaCl, NaBH4, right? Potassium, KCl, MgCl2, right? That too. Okay. Actually, other two are very rare, right? Write down, availability, sodium chloride, borax, and potassium, KCl, and KCl, MgCl2, H2O, called carnalite. Right. Then we have to talk about the group trends, right? We will talk about different trends. And another thing in this lesson, right, before we write different reactions, not like previous lessons, here we don't need to mention physical status like in the physical chemistry, right? You have to, I told it, always, right? I think I said that even when you learn physical chemistry part, right? Just remember, in inorganic chemistry it's not compulsory, right? They don't care whether you put physical state or not, right? If you put it, correct. If you didn't put that, if you don't put that, again you are correct, right? They don't care, right? But it should be balanced, huh? I mean, if it's unbalanced, it's wrong. Stoichiometry, it's compulsory, right? You have to balance it. But physical state is not necessary, right? If you like, you can put it, but no need to do that, right? Okay. Just keep it in your mind, huh? And okay, write down the subtopic group trends. Okay, group trends. So I will put the table, right? So then you can understand the basic trends, right? You know how to write the electron configuration, right? No need that. Melting radius, sorry, metallic radius. Metallic radius. Next one, melting point. Melting point. Melting point. Radius. Can you see the board? Hardly. Radius. First ionization, second ionization, first ionization, second ionization, right? Lithium, sodium, potassium, rubidium, cesium, Cs. Metallic radius, right? May I write it? Radius, first ionization, second ionization. This is melting point. This is metallic radius. These are real values, huh? Metallic radius from PM, petameter. Lithium 152, 186, 231, 231, 244, 262, right? Melting point Celsius 180, 98, 64, 39, 29, right? 29 actually. if you have you seen cesium, right? Actually, I didn't touch that. I never touched that. I saw some videos in the YouTube, right? Actually, they place it by sealed glass tubes, right? So when you touch it, right, when you hold it some time, I mean 5 to 3 minutes, right, 2 5 minutes, it will melt, right? Melt like mercury, right? And again, if you remove that, it will solid, okay, because the temperature is 29, right? They always keep it sealed, right? I mean, how do you keep sodium in the uh, hydrocarbons, right, inside of the hydrocarbons, right? But this one, they keep it sealed, right? Not, they don't allow it to contact with anything, right? Okay. Then radius, no, oh yeah, radius of radius of ion m plus ion pm 59. You don't need to memorize those numbers, 102 138 148 174. Then first ionization energy, kilojoules per mole, 520, 495, you know this pattern, 418, 403, 375. Second ionization is 7298, 4562, 3052, 2633. Wait. This one also kilojoule. Two, 3, 4. Right? So you don't need to memorize those patterns, right? But just check these patterns. Right? How is change? Right? Metallic radius. Metallic radius is increasing. You already know that. Why? The energy levels are increasing. The number of electrons are increasing. Right? And melting point, it decreases. Why? When the metallic radius is increasing, you know about the metallic bonds, right? So when the metallic ion is become the metallic radius, right, the radius of the metallic ion become bigger and bigger, it's hard to hold, right? So then melting points, boiling points decreases, right? And another thing, it's generally all the first group elements have all the first group elements have lower melting points. Why? Their charge is lower, right? They have lower means L +1, that's it, right? But the metals like, I mean, Fe, like, right, they can release more electrons into the pool, right, into the outer. So then they can make a good electron pool, and their charge is higher. They cannot make more than 1 plus. Why? It's hard to form 2 plus or 3 plus. They have higher ionization energy. The second ionization energy is very high compared with the first one. Therefore, they cannot have that kind of ions. So, therefore, their metallic structure is weak, right? That's why they have lower melting point. I mean, overall lower melting point, and it reduces due to the ionic radius, right? It reduces due to ionic radius. When the metallic ion become bigger and bigger, they have lower melting point, right? Then ionic radius, right? Then you can understand that the same thing happened to plus ion also. That one metallic radius, this one ionic radius. Okay. First ionization energy, it's very low. It's a common factor. It's reducing by the electrons go away from the nucleus, and the same thing applying to second ionization energy, right? You should know how it's happened, right? Right, these are the basic patterns. Then you know metallic radius is decreasing, melting point decreasing, metallic radius increasing, melting points decreasing through the group, radius is increasing, ionization energies decreases through the group, right? So copy the table, right? Copy the table. Right. Then you can mention it separately. Melting point decreases, right? Likewise, just mention it by yourself. Right. Then these are the basic patterns, right? And then we will move to reactions, right? What type of reactions they are showing, right? So you don't need to memorize these numbers, right? Just memorize. I mean, just understand what type of patterns, right? So then let's move to reactions. Okay, copy the table, right? Okay. Right. And another thing, upload the notes after watching the lesson. Okay, write down main topic reactions of group 1 elements, and then subtopic reactions with water, right? Reaction with water. Okay. Right. Okay. So you are familiar with this reaction, right? With water, right? It's a you do this experiment from grade 7, 8, right? What happens when you put sodium into the water, right? We put very small piece of sodium, right? What you can observe, it react vigorously, right? Rapidly, right? As your teachers said, I mean, from your early days, I mean, your previous grades, right? Never put it into hot water, right? We put it into cold water, sodium, right? So the reactivity, right? When you compare the reactivity, it's increasing, right? The reactivity increasing through the group, right? So when we come to lithium, it's not reactive like sodium, okay? It's not reactive like sodium, but sodium react vigorously, and potassium, it's more reactive than what? It's more reactive than lithium, sodium, potassium, rubidium, cesium, right? Lithium, right? It's react slowly, right? It's react slowly. Sodium, it react vigorously. And potassium, it's vigorous. This is the way we explain it, vigorous and ignites. Right? This one, these both rubidium and cesium we call explosive, right? If you like, just watch some videos. There are crazy people in YouTube, right? I mean, they put cesium, rubidium, right? Those things into the water, right? I mean, not cesium. I mean, huge chunks of potassium, sodium, rubidium, right? It's like a bomb, right? When you put it in water, it's blast and go to the sky, and then again jump into the, then again it's react, right? So how it's react? Remember how it's react. You know these reactions. Sodium, I mean, we get sodium, it's reacted to water by releasing what? It releases H2 gas, right? H2 gas. And what happened to the solution? It's become basic. That means sodium hydroxide, right? When you do this reaction, if we put the flame, you can see it start to burn, or sometimes it's automatically start to burn, right? The flame, how it's get flame? This hydrogen. If that hydrogen is start to burn, it's a flame, right? Right. This is the thing happen. We can write that equation, I mean the common equation, like this is not balanced. Put 2, now it's balanced. Not yet. Now it's balanced. Okay, we can write the common formula. If we take m, right? 2m plus 2h2o, 2MOH, MOH plus H2. Okay. Just write down group 1 elements, group 1 metals, group 1 metals react with water, 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 and release hydrogen gas and form hydroxide. Release hydrogen gas and form hydroxide. Then write down this equation and this equation, both, right? Both equations, and after that this one. React slowly, vigorously, and ignition, then explosive. This cesium is very expensive. These are expensive than gold, I think. It's not that much expensive. Why? It's not available, right? These kind of elements are not available. I mean, it's hard to find, right? You can find if you have money, right? Hard to extract, and it's not available in the nature, right? Then after write this reaction, write down with this star. These reactions are highly exothermic. These reactions are highly exothermic except lithium. Okay. It's not that much exothermic. Why? It occurs slowly, right? Except lithium, right? Underline that sentence. Not highly exothermic. Other metals highly exothermic, right? Lithium, it's an exception. So just remember, right? You can understand it. Lithium. So he's different, right? He's a metal, right? I mean, he's close, not like hydrogen. He is in the family, but he is a different one, right? He has different characters, right? Kama family එකේ අර එහෙම ඉන්නවනේ. පවුලේ 4 දෙනෙක් දැන් 5 දෙනෙක් ඉන්නවා. 5 දෙනාගෙන් 4ක්ම එක වගේ තමයි. අර නිකන් අර මේ ටිකක් වෙනස් එකක්. හරි? වෙනස්කම් තියෙනවා ටිකක් ඈ. ඒක කියලා දෙන්නම් ඉද්දිය. right. එක වෙනස්කමක් එනවා මෙතන. Then write down the subtopic reactions with oxygen / air. 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 Right here, lithium, as I said, is different. This lithium, it's react with nitrogen and oxygen both, right? It can react with both, but others cannot react with nitrogen, right? Others cannot react with nitrogen, so they are react with oxygen, right? React with oxygen. Generally, the general equation, actually not general, there is not general equation. You can write general equation, but it's not common, right? Lithium, it's react with lithium lithium react with oxygen and form LiO2, right? LiO2, Li2O, right? No, here 4 should be balanced, balance in right? Okay. How about how it's react with nitrogen? It's react with nitrogen like this: 6 Li plus N2, 3 Li, sorry, 3 2 2 Li3 N, right? That's it. Again, right? So that means, right, just understand, if you burn sodium in normal atmosphere, you can have both. I mean, you can have two compounds, lithium oxide and lithium nitrite, right? Both. But if you burn sodium, you cannot have sodium nitrite. Okay. Just write down, lithium can react both oxygen and nitrogen. Then show this equation. Lithium can react both oxygen and nitrogen. Right, this reaction. Okay, and then next sentence, right? After that, next sentence, both sodium and potassium do not react with nitrogen. Point taka. Next point, both sodium and potassium do not react with nitrogen, right? Underline it. Underline it. Only lithium. Then what they can form? When sodium burn in air, wait, just write down, leave the rule and write down. When sodium burn in air, sodium peroxide is mainly produced. Sodium peroxide is mainly produced with some sodium oxide. Right? When sodium burns in air, sodium peroxide is mainly produced with some sodium oxide. This is the reaction. Two Na plus O2 form Na2O2, right? This is peroxide, O2 2 minus, right? Just mention it. I think you remember. If you cannot remember that, just mention it. That this is peroxide. Okay. O minus means oxide. Right. This is the reaction. And you can find that, the common one, this is mainly, then I'll write that one also. small amount, right? This is the main one. Right? And then after this reaction, write down uh, next point, potassium burned with air, hurry up, potassium burnt with air and formed potassium superoxide, potassium superoxide, formed potassium superoxide. What is superoxide? Superoxide means O2 minus, right? Oxide means O2 minus. This one O2 2 minus. Superoxide means O2 minus, right? Superoxide. Write down potassium burnt in air, burnt with air and formed potassium superoxide. Potassium superoxide as the main product, with some potassium oxide, and potassium peroxide, right? Potassium oxide and potassium peroxide, right? All the three compounds are formed, but mainly potassium superoxide. In previously, when we learned, we just said only superoxide, right? Here they mention both are formed, but little bit, right? Small amounts, right? Write down the equation. Superoxide one. Potassium plus O2, right? O2 2, sorry, not 2, KO2, yeah, KO2, right? That's it, KO2, superoxide. Potassium superoxide, okay? Right, underline that sentence and write down this formula, equation, right? Okay, that's it. Right, and after this reaction, just write down group 1 metal oxides, group 1 metal oxides react with water, group 1 metal oxides react with water to produce metal hydroxides. This kind of things asked in the MCQ, right? They give some sentences, right? Then they can check it easily whether you know or not. දන්නා නැද්ද කියලා ටක් ගාලා බැලුවා සෙන්ටෙන්ස් එකක් කරකවලා දීපු ගමන් හරි. plus H2O right. ඔය peroxide එකක් වතුරට දැම්මහම it form hydroxide, right? Okay, done. So I explained that part, lithium formed Okay, no need to do it again. Then next one, next point, group 1 hydroxides, react with carbon dioxide. Group 1 hydroxides react with carbon dioxide to produce relevant carbonates and further react with carbon dioxide to produce metal hydrogen carbonates. Further react with carbon dioxide to produce metal hydrogen carbonates. Right? Okay. What is that? When you send the carbon dioxide, this thing common for second group also. When we send carbon dioxide through the hydroxide, it form sodium carbonate, right? It's carbonate, right? Whatever, right? Then release H2O, and if we send more carbon dioxide into the solution, it will start to react with sodium carbonate, NO2 CO3 plus CO2, it form 2NaHCO3, right? Write the equation. Okay, then next one, reaction with hydrogen gas. Subtopic reactions with hydrogen gas. Okay. Write down the first point. Group 1 elements react with hydrogen to produce solid ionic metal hydrides. Okay. They can react with hydrogen and form metal hydrides. Sodium plus H2 form sodium hydride, right? Write the equation and then write down. Here, what is the oxidation number of hydrogen? Hydrogen has -1 oxidation number, right? Just mention that oxidation number. -1, right? Write down this hydride reacts with water. These hydrides these hydrides react with water. These hydrides react with water and produce and release hydrogen gas and release hydrogen gas. Just write down release hydrogen gas, it's enough, right? Reacts with water and release hydrogen gas, right? And actually it's formed hydroxide, okay? NaH plus H2O formed NaOH plus H2. Right. Then next one, copy the equation. Then next one reacts with acid. Reacts with acids. Reactions with acids. Reactions with acids. Next topic, next subtopic. Here we are talking about different reactions, right? Why it's important? It's important to identify and to do some experiments, right? It's important. It's a nature, right? You can identify the characters, okay? Reactions with acid, I mean, as you know, we never put these metals into acids, right? If you put it, it's react vigorously, not vigorously, actually it's explosive, right? Group 1 metals vigorously react with dilute acids. Group 1 metals vigorously react with dilute acids. Group 1 metals vigorously react with dilute acids and acids to produce hydrogen gas, and relevant metal salt. Hydrogen gas and relevant metal salt. Actually, you are familiar with some reactions, huh? No, not everything, not all the things are new. You know some things already. So let's write some equations. Lithium react with HNO3 form lithium nitrate. 2 sodium with H2SO4. We cannot do this kind of reaction. Someone may die if you're gonna do that, right? Or severe burn, right? You may end up on the in the ICU, right? If you do it in your school laboratories, right? But you can do it under safe environment. These are also dilute, huh? Right. How to see that? Just write aqueous, it's enough. AQ. That means dilute. H2. So I put AQ for mention dilution. Huh? Na2SO4 plus H2. Right. Okay. Copy the equation. Okay, then write down the main topic. thermal stability of salts, right? Thermal stability of salts. Thermal stability of salts. Thermal stability of salts. Thermal stability of salts. Okay. Then subtopic decomposition of nitrate. Subtopic decomposition of nitrates. Decomposition of nitrates. Can you understand how much theory in this part? Right? Still we are in group 1, right? Not finished, right? So that's why we say this is a very big lesson now. So here under thermal stability we will discuss what happened when we heat the salt, right? How it's break down. Okay. Here decomposition of nitrate, we will heat nitrate and we'll check what happened when we heat it. Okay. When you heat it, like lithium nitrate, right, what will happen when you heat it? It's produced lithium to lithium oxide and 4NO2 plus O2. Right. As I said, lithium is a different one. So look at the reaction. Look at what happened when we heat potassium, right? When we heat lithium, what happened? It's break down into lithium oxide and it's release NO2, right? Nitrate and nitrogen dioxide and O2. Right? But when we heat potassium nitrate, it's just release O2 gas and NO2, right? Potassium nitrate, it's become potassium nitrate. Potassium nitrate and it release oxygen, right? This is the thing happen. So just remember, lithium is a exception, right? This reaction is common for sodium also, right? Write down. Group 1 nitrates are used as fertilizers and explosives. Group 1 nitrates are used as fertilizers and explosives. Right? Write down. Lithium nitrate decomposes according to the below equation, decomposes according to the below equation. And write down the equation of lithium nitrate, and then write down the equation, and then write down after that Other group 1 nitrates produce relevant metal nitrate and oxygen. Other group 1 nitrates produce relevant metal nitrite and oxygen. Then write down the equation of potassium nitrate. Right. So here we talk about nitrates. Next one, carbonates. So write down the topic: decomposition of carbonates. Decomposition of carbonate. Right. As you know, it's common for all the group, right? So when we heat the carbonate, it releases carbon dioxide and it's form oxide, right? Write down. Carbonates are stable. And melt before decomposed into oxide. Carbonates are stable and melt before decompose into oxides. Next rule, lithium carbonate is less stable. And decomposes readily. මේ ලිතියම් කාබනේට් ටිකක් යන්නේ ඔය සෙකන්ඩ් ගෲප් එකේ උන්ගේ වගේ පොඩි කැරක්ටර්ස් තියෙනවා මම ඒක එක්ස්ප්ලেইন කරන්න මේ උගේ පොඩ්ඩක් එහෙම කැරක්ටර්ස් තියෙනවා නිකන් ලාවට ඔළුවේ තියාගන්න so here lithium is unstable, right? Others are stable, so that's why they can hold until it's melt, right? After melt, then it's decompose. Okay, lithium is less stable, right? If you heat it, it's quickly break down into carbon dioxide, but the way they decompose, right, is similar, right? The way lithium decompose is the way other elements decompose, other carbonates decompose. Okay, write down the equation: lithium carbonate break down into lithium oxide plus carbon dioxide. Have you wrote the topic decomposition of carbonates? Decomposition of carbonates. Okay, then next one, decomposition of bicarbonates. Next topic, decomposition of bicarbonates. right? Decomposition of bicarbonates, right? Uh, Nothing is special, right, about that, but the stability of bicarbonate, the stability is increasing through the group, right, down to the group. Okay, uh, this is the way it's decompose, right? Just write down the equation, it's enough. Sodium bicarbonate, this is a common equation. Na2CO3 H2O plus CO2. Then write down the equation and write with this star. Copy the equation and write with this star. Thermal stability increases down the group. Thermal stability increases down the group. Right. Then next main topic. Write down solubility of group 1 salts. Solubility of group 1 salts. Okay, solubility of group 1 salts. So here write down the subtopic solubility of halides. Okay, before that, just write down, uh, all group 1 salts, are soluble in water. All group 1 salts are soluble in water except some lithium salts such as lithium fluoride, lithium carbonate and lithium phosphate. Just write this and underline. Right? These are white salts. White color. Mention it properly. Right? These are the only insoluble salts. Okay. Then just write down a sentence. The solubility of halides of sodium. Right. The solubility of halides of sodium. As you know,